What's up? Welcome to Models and Agents, episode 61. It's May 27th, 2026. Lots of news to walk through. Let's start with what actually matters. Anthropic just published concrete sandboxing patterns that let agents scale capabilities without expanding their blast radius. The briefing today centers on new sandboxing techniques for agents, fixes to speculative decoding, and several fresh agent frameworks plus evaluation tools. 3 model updates focus on inference stability and post-training methods. Agent tooling includes a Rust coding agent and a prompt optimizer that uses sandboxed execution. One community project improves how multi-turn conversations turn into benchmarks. Anthropic released a new engineering blog post on sandboxing for AI agents. The post stresses that permissions must evolve alongside agent capabilities. Sandboxing limits the scope of potentially destructive actions in their products. The guidance favors starting with narrow permissions and expanding them only after demonstrated reliability. Builders can apply the patterns when granting file system, network, or code execution access. The approach avoids reliance on static rules as agents gain autonomy. Similar sandbox designs are likely to appear from other labs soon. Now let's move to the model updates. The Eagle team, VLLM, and TorchSpec released Eagle 3.1. The update targets attention drift that caused inconsistent draft token acceptance rates during speculative decoding. Teams running high-throughput inference pipelines can integrate the algorithm to reduce variance in latency. The release prioritizes production robustness over raw speed gains. Builders should test the updated path if they see fluctuating acceptance rates on long contexts. Researchers introduced self-verified distillation as a post-training method. Models generate, self-verify, and train on their own solutions using only unlabeled prompts. 3-stage filtering covers cycle consistency, factuality, and correctness. QW3 to 4B showed gains of 16.7 points on math benchmarks, 11.1 on science, and 8.3 on coding. The method requires only a single inference call at test time. Teams fine-tuning smaller models should experiment with the pipeline when labeled data is scarce. Microspec introduces a training-free method for speculative decoding. It builds compact, context-sensitive vocabularies on the fly. Average vocabulary size drops by more than 40 times while maintaining coverage through temporal locality. The system achieves 51.6% lower draft latency and 1.12 to 1.32 times end-to-end speedup over Eagle 2. Inference teams should evaluate it when vocabulary projection is the current bottleneck. Now for agent and tool developments. VT Code is a new open-source Rust TUI coding agent. It uses AST-level chunking and explicit token budget tracking to avoid dumping entire directories into prompts. The agent supports macOS Seatbelt, Linux Landlock, and Seccomp sandboxing, plus tree sitter validation on every generated command. It works with any OpenAI-compatible provider and includes a config example for routing through endpoints like DeepSeek v4 Flash. Developers tired of token waste in agent coding sessions should try the MIT-licensed repo. HiveMind is a desktop app that combines 3 AI-assisted development modes. The modes cover focused task planning, concurrent multi-model review called HiveMind, and fully autonomous multi-feature execution called Swarms. It supports providers including Anthropic, OpenAI, Ollama, DeepSeek, and NVIDIA NIM. The project is seeking testers before full public release and is available on GitHub. Users can export and reuse swarm plans across different model compositions. Spear turns automatic prompt engineering into an agentic process. The system is called Sandboxed Prompt Engineer with active rollback. It includes 4 tools with a Python sandbox for structural error analysis. Spear outperformed prior methods on 13 industrial LLMs, as judge tasks, and 7 BBH tasks. The Python tool provided the largest single contribution on complex judge tasks. Auto rollback prevents metric regression during optimization. Prompt engineers working on evaluation pipelines should test the agentic approach. In the practical and community section, Comp2Bench automatically converts real multi-turn user assistant dialogues into structured requirement checklists. Applied to programming tasks, it produces benchmarks with near-perfect Spearman correlation to human-authored sets like Big Code Bench. The LLM as judge component reached substantial agreement with human ground truth at kappa of 0.705. The framework reduces the cost of maintaining high-quality evaluation sets as models evolve. Evaluation teams should examine the pipeline for their own domain-specific benchmarks. Okay, let's pop the hood on speculative decoding stability. Everyone talks about speculative decoding as a simple speed trick. In practice, it balances draft model quality, acceptance criteria, and attention stability across layers. The mechanism lets a smaller draft model propose multiple tokens that the target model verifies in parallel. Attention drift occurs when the draft model's hidden states diverge from what the target would have produced at the same positions. Divergence grows with sequence length because each accepted token shifts the key value cache the target model sees on the next verification step. Eagle 3.1 and similar fixes add lightweight correction terms or renormalization steps to keep the draft distribution aligned. These corrections cost a small amount of extra compute per verification round. The corrections buy back 10 to 20% acceptance rate on long contexts while adding roughly 5 to 8% overhead to the verification pass. Use the stabilized version for any production workload where tail latency matters more than average throughput. Skip it for short, bursty requests where drift never has time to accumulate. Things to try this week include testing Eagle 3.1 in your VLLM setup if speculative decoding acceptance rates have been drifting on contexts over 8,000 tokens. Clone VT code and run it against a local DeepSeek endpoint to measure token savings on a real refactor task. Apply self-verified distillation to a 4 billion or 8 billion Qwen3 model on your domain-specific unlabeled prompts before the next fine-tuning cycle. Experiment with Spear's Python sandbox tool on an existing LLM as judge task to see how structural error analysis changes prompt quality. On the horizon, more labs are expected to release detailed sandboxing and permission frameworks as agent deployments move into production environments. Additional papers on agent credit assignment and retrieval-aware training are likely following the Rice PO and Spear releases. Open-source coding agents with stronger AST-aware context management will continue appearing on GitHub as teams share their internal tools. Tomorrow, keep an eye on further details from labs expanding sandbox designs for production agents. That's models and agents for today. If you found this useful, share it with someone who's trying to keep up with all these changes, and subscribe so you don't miss tomorrow's update. The AI world moves fast. We'll help you keep up. See you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.